Hello, everyone. Welcome to another episode of Scaling with Demi. Today, I'm talking about a concept that is pretty important to product managers, software engineers, front end, back end, database analysts. Kind of like everyone in tech, which is a concept called latency, right? I think I see everything is important. This one is one of those things that are actually important. But what really is latency, right? Latency is, there are many ways to describe it, but latency is the time it takes from a request to go from one system, the phone, a server, a laptop, to another system, right, which is another server or another phone, and for you to get a response. There are many things that contribute to a very high latency, but you want your systems to have as low latency as possible, except for whatever reason, part of the design, you need it to high latency. But on average, ideally, you want your system to have very low latency. And so in this video, we're talking about some of the causes of high latencies. Look how we can optimize it, database queries, network servers, load balancers. We'll brush through it and hopefully we can learn one or two things about latencies and how to improve it. So let's go. So latency is the amount of time, like I said earlier, right? Latency is the amount of time it takes from a request to travel from one system to another. You might think when you just go, if you've watched other videos I've talked about, you know that your files, the internet, the HTML files, the images on the web, your TikTok videos, your Instagram videos, your YouTube videos are stored on another person's computer, which we like to call servers, right? But these are just another person's computer. They have their own RAM, they have their own CPU, they have their own memory. They might not have a monitor, but it's actually still like a system itself, a computer. So when we go to the browser, we need a way to fetch these files, to fetch these records from a database, to fetch these files, to fetch my user profile, to fetch my videos, right? So we have to make a request to these servers. So you might just assume that I just go to tiktok.com or I use the TikTok application and all my videos just get loaded automatically. But then there are a whole lot of things that happen behind the scene. A host of files are being fetched, a host of records are being queried, a lot of dramas are actually going on behind the scene. And this could, if it's poorly designed, it could contribute to a system that takes extremely long to load. We all have that experience with applications that take very long to load. So this could contribute to that significantly. So for example, I'll just do a quick demo here for you to have an idea of how a request is made from a client, from a browser. So as I go into the more detailed things, you have more context. So this is an incognito mode on my computer. Let me go to youtube.com and I would open the inspect element there for you to see all the requests that is being made. So I open the inspect element, I go to the network tab, and here we can see all the requests, all the files that are being fetched, just for YouTube to work. So here you can see we have a file here. I don't even know what this file does. We have so many. This is a .js file, which is a JavaScript file, desktop polymer, probably does something. This is another web animation file from youtube.com. So there are so many files that are being stored, and this contributes significantly to how long it takes for your application to load, for your website to load, or for even a simple request to the backend to load. Now, in my inspect element, I actually disable cache so that it forces a reload whenever I reload the site. It doesn't load it from cache. So let's just take a look at the some data here. We can see that about 2 MB of files were transferred, 53 requests, and we can see this. And we can see the time it took for each of these things to be transferred. Right, you can see this remote.js file, for example, took about 79 milliseconds. This remote.js took 1 milliseconds. This create took 204 seconds, 204 milliseconds. So at the end of the day, right, how long it takes for your site to load is a sum of all the files that are loaded. If you do it correctly, it's the sum of all the files that are loaded or all the data that is loaded on the front end or by the request, aggregated together, right, the sum of it. So there are hacks that you can actually do to make things load faster, even though you have a lot of files. One of it is to reduce the file size. The other is to load it asynchronously. We'll go through it. But this just gives you a sense of some of the requests that are being made. There are different types of requests. So let me limit it to fetch requests, which are like JSON kind of requests. So let's see. This is a fetch request. A get request. Let me look for another. Is a response. Yeah. So how long does this take? So this is a get request, a simple get request. It takes about 208 milliseconds. Let's just try to see the performance insights. Let's run Lighthouse first, actually, and just see how long it takes. I don't care about SEO for this. I don't really care about best practices. I just care about performance, right? I just care about performance. So let's run it and see how long it takes to load. So this lighthouse will check the performance across different devices, across different systems. Let's see what we get. So looking at this here, I'm surprised YouTube has a performance of 35. Something might be off. It's supposed to be better than this. But you might not have the luxury of YouTube in your organization or for your product to be a little bit slow and still have a lot of users. So for example, you can see the first content footprint 8.3 seconds. Let's expand this. So the first content print, the timing with the first text or image, so it takes 8.3 seconds for you to show. That's not great. Like that's a little bit slow on the slow end. Might also be because of my network, but that's slow. Time to interactivity, you can't interact with the interface until 15 seconds later. Now, in terms of latency, right, you can take of it in terms of a website, how long it takes for a website to load. It could also be in terms of a request, how long it takes for a request to be resolved. You can look at it on a per request level or as a whole. I mean, these are just terminology you're using just to measure the time it takes for something to communicate to another thing, really. Right, one network system to communicate to another network system over the internet or over whatever protocol it's using. So you have the speed index, total blocking time. So yeah, there are a lot of ways to prevent your system from having a very high latency or to optimize it. We would brush around that. But before I do that, let me just walk you through what really happens when you make a request. On the surface, right, what really happens when you make a request to a server, right? So there are a lot of systems involved. It's not just direct. So you might think naturally like, this is you. Maybe your name is Demi. This is a server. In an ideal world, when you make a request to a server, the request just goes zoom and get a response, zoom, and everything's as fast as it gets. But we know that the world is largely not ideal. I mean, that's an over-exaggeration though, but we know that things are not like that. So what really happens is you make a request to a server. This is your browser. This is you. You carry your browser. My diagram is very ugly, but this is my browser. Then I put in, say, facebook.com. This goes to Facebook. This makes a request to the DNS. So the DNS system is what I've talked about it so many times in the past. The DNS system is what actually stores the IP address to the domain name mapping, right? So actually the IP address. You can't just go to an address without knowing to a domain name without knowing the IP address it maps to. I talked about it in some other video. Just subscribe and like so you can receive other videos I've posted and check out some of the previous videos where I actually talk about DNS. But then the browser has to identify, okay, what's the IP address of facebook.com in this case, or tiktok.com, or instagram.com, right? So it makes a request to the DNS server. This has an overload. This actually has a time it takes to do it, so it adds to the latency a bit. Get a response. Usually the browser just actually caches this response the first time it makes a request. Even the DNS also caches it. One of the solutions to latency, we'll talk about that later. But the first time it's going, it makes a request, gets the IP address that maps onto facebook.com. If you're using HTTPS, it makes a request to the server. Before we even get to that point, after getting the IP address, so now it has the IP address for facebook.com, then it makes another request to, and all these requests it's making, right? It makes it to your telecom provider. Even the DNS request actually too went through your telecom provider. So it makes your telecom provider. Yeah. It makes it to your telecom provider. And if you're using something like Starlink, for example, it makes it to your Starlink makes a request to the satellites, then that will make a request back to the providers of the servers. But if you are using a regular telecom, it makes a request to the telecom provider. This ones, they make a request via maybe undersea cable or satellite or whatever. They make a request to that, using that. Now, like I'm saying, each of these systems actually adds additional time to the request. Then when this is the undersea cable, So the request just goes like a normal request to the undersea cable. Then it goes to the telecom provider of the server you are trying to access, right? What is the telecom system that is responsible for putting that server on the public web, on the public internet? The chances are the server themselves might be managing their own telecommunication system, or they might be outsourcing it to some other telecom to list them on the public internet, right? So they make a request to that. So I'll just put another telecom provider here. Then the telecom provider makes a request to the servers itself. And this just happens just to even say, oh, this is an HTTPS request. Let me maybe just get a contract to you that, oh, you're actually the right server. You give me an encryption key. Then I do all this again. Then once it has gotten the server now says, oh, this is the file you're looking for. It could be a CSS file. It could be a JS file. Remember the network tab we checked for this. Because there's so many JS files, so many CS files. All this is happening for all the files that are being set. Now, there are ways to optimize this. It doesn't have to be all this dramatic. There are ways to make it better. But for all the CSS files, the JavaScript files, every request, all these processes actually go through, went through. Then the server responds with the data or the CSS file or the record back to the telecom provider, back to the undersea cable, back to your own telecom provider, back to you. Each of these adds a latency to the request. Each of these takes time to actually be resolved. Now, on the server itself, on your own backend application, maybe you unfetch the user profile, just the server part here, right? The application does some complex looping, some for loop, some find. It makes a request to a database. The database might be on another system entirely. So let's say you have the database hosted in South Africa, for example. That one makes its own request using this old dramatic process again. To the database, you get the response using the same dramatic process. Now, all this happens within milliseconds because, it's light, right? It's light moves at 3 times 10^8, 2.99 actually, but approximately 3 times 10^8. All this happens very fast, but there are some things that might make things slow down, right? Because in terms of like the bandwidth you are located with, the speed of your internet, the speed of the cable, is there a broken cable or not? Are there errors in the transfer? If you store the database in the same place you are storing your servers or in your backend, you can be guaranteed that it's going to be a little bit faster to call your database because it's not making requests to the network. So all this now contributes to you having a system that, I can't load my website in 1 millisecond and my website is available or everything is available. Everything just works. The more videos you have on your website, the longer it takes. For a normal REST API request, that's a lot faster because you're not really loading videos, just TXT, except you are loading large TXTs, which is another thing entirely. You should not be loading blobs as REST, ideally. But if you're just loading raw, simple strings, it's going to be a lot faster because the strings are like 1 KB, 1 byte. They're not usually large, the JSON response. But still, the request has to go through each of these channels for this. So now that you understand how the pathway that request takes ideally, what are the things that actually contribute to having a very slow system? You're a product manager. Your boss is complaining that the application is taking too long to load, or the requests are taking too long to load, or you integrated a third-party API that just takes forever for your request to be resolved. What are some of the things that could contribute to this? So what are some of the things that could contribute to this? And in this whole world system, there are so many things that contribute to this, but what are examples of things that contribute to this? One is if your database is not optimized. Like I mentioned, you need to make a request to the database. If you have unoptimized queries, I'll give more practical example and tell you how to solve it in the next video. But if you have bad database queries and your queries are taking 1 second to load, then you can be rest assured that your site is going to take at least 1 second to load, 1 second plus every other thing, the sum of every other, the time between every other request, right? So you want to optimize that. Now, in this kind of system, when it comes to latency, your system is only as good as the sum of all the system, right? So the weakest link actually contributes significantly to the slowest part of your system contributes significantly to the speed of the system. So bad queries in your database, we'll talk about how to optimize it, we'll talk about some of the ways to do it, talking about aggregation or even breaking down queries into smaller pieces, how changing the CPU and the RAM of your database could impact the speed of your system. In the next video, we'll talk about that. But not having a well-written query, not having indexes could actually significantly lead to a slower system. You also have an overloaded database. Your database is not the right CPU, not the right RAM. You can be sure that would lead to a slower system, definitely, because of it. There's a limit to what you can process at a time. Then if your logic is dependent on some third-party integration, maybe you integrated some fintech application, some verification application, these guys, you need to query them, and their own inefficiencies could end up leading to a very inefficient system for you. So you want to also be very sure of the third-party systems they're implementing, look at their speeds, look at their metrics, and as much as possible, the ones you can do asynchronously, you can actually do asynchronously, which leads me to another thing that causes a lot of high latency system, is where you have a lot of synchronous codes. Right, there's some things that doesn't need to be done in that single flow. You can actually give a response to the client or to the user and do those things in the backend. So you want to keep them asynchronous using queues or using just the generic Node.js event loop. Keep those things asynchronous. It makes your system faster. Then you have the size of the content you are loading, right? The larger the size. So if I'm opening an application on my phone and it's loading images, simple images, and the images are 1 gig in size, you can be rest assured that I'm going to take a little bit of time for it to load and make it look like this website is very slow. Alternatively, if you're sending in a lot of unnecessary response to the front end in the simple REST API, you can be sure that it's going to take a lot of time for it to actually send over the network, because each of this the data has to move through this as packets through this the fiber optics, the telecom systems, your own server, your own network, your own bandwidth. So you can be sure that it's going to take a little bit of time for it to load. Then you have the security or the encryption protocol that has been implemented, right? If you've integrated HTTPS, your laptop or your client, your browser has to make a request, first of all, to establish the connection, the SSL connection with the server, before it can even do anything to secure the connection. That adds to the time. The more complex encryption you add, the longer it takes. Now, everything in tech, or almost everything, even in life generally, is mostly about trade-offs. You gain some, you lose some. Not much you can do. So in the next video, we'll be looking at how some of the things you can do to improve the latency of each of these parts. Right? How do I optimize my database? How do I optimize the network layer, the application layer? What are the things I can do to make my things perform better, to make my application faster, to make my API faster? Or as a product manager, what can I communicate to my engineers to do in order to improve the efficiency of my system? See you in the next video. Cheers.